Okay, today we're going to be talking about balancing chemical equations. All right. And so when we go into this, we're going to first need to define a few things. And so we have our introduction to chemical reactions here, which is a few definitions that we're going to have to nail down. And so there's really four big definitions on this page that we want you to get. There's a coefficient, the subscript, and then reactants and products, which we'll get to. So first, we need to tell the difference between a coefficient and a subscript, which is fairly simple. A coefficient is going to be a small whole number in front of the formula in the reaction. Okay, these things right here out front, the 2 before the H2O, the 2 before the H2, those are coefficients. They're going to be used to balance, which is what we're going to be doing today. Whereas a subscript is going to be that number to the bottom right of an element that tells you how many of something there are. So in H2O, that 2 tells us there's 2 hydrogens. O2, there's 2 oxygens. H2, there's 2 hydrogens. In a propane like C3H8, you'll have 3 carbons and 8 hydrogens. That's the difference in the subscript. When we are balancing today, you cannot ever change the subscript. You can, however, change the coefficient. In fact, you're going to have to. All right, so subscripts you can never change because that'll change what you're talking about. If you take H2O and instead make it H2O2, that now becomes hydrogen peroxide instead of water. So we can't change that. So when we look down here at our reaction, we also have a breakdown where you have the reactants on the left, the products on the right, and that is of the arrow. And that arrow lets us know that a chemical reaction is taking place. So on the left-hand side, you have the things that are going to react, the reactants. And on the right-hand side, you have what is being produced, the products. And again, this arrow indicates the chemical reaction. All right. Now, what we have to go over first is the law of conservation of matter, which states to us that matter cannot be created nor destroyed. It can only be changed. All right. And so when we think about what does that mean, what we're saying is what goes in has to come out. If you're baking chocolate chip cookies and you put, cookies that have 20 chocolate chips into the oven, when they come out, they can't suddenly have 10 chocolate chips or 100 chocolate chips. They have to have 20, right? Whatever you put in has to come out. Well, the same is true of a chemical reaction. If you put in a certain number of an atom, in this case, let's look at oxygen, the red ones here, right? You're putting in 1, 2, 3, 4 oxygens. Well, when that reaction takes place, 4 oxygens have to come out. 1, 2, 3, 4. Okay? In order to show this, we balance the equation. We use these coefficients, which tell us we have to have a certain number of these O2 molecules, and over here, a certain number of H2O molecules to balance out, to make sure that whatever goes in has to come out. Okay, so we can't just have less come back out in a chemical reaction. It has to be the same, and that's kind of the guiding principle behind balancing chemical equations. We're going to make sure that whatever goes in also comes out. So let's just jump right into it. And we're going to start off with steps 1 and 2. We've combined these because, first, it's a little wordy, but also it's the very beginning. It's how you make what's called a skeleton equation, which we're going to come back to. So step 1, or rule 1, is going to say determine the correct formula for all the reactants and products in the reaction. Now, our example is down here at the bottom where it says nitrogen gas, N2, reacts with hydrogen gas, H2, to form ammonia, NH3. Well, we've already given you the correct formula. So this first thing, it basically tells you, well, you need to know nitrogen gas is N2, hydrogen gas is H2, and then ammonia is NH3. We're going to give it to you in parentheses each time. But in other classes, at other levels that you go on, you might need to come up with these on your own. And then there are certain rules that we didn't cover. So step 2 then is you need to write these in that formula, right? Reactants on the left, products on the right, add plus signs if there's more than one on a side, and separate them with that arrow. So let's go ahead and organize this, right? So we go in and we say, well, nitrogen gas, N2, right, reacts with hydrogen gas. So we can say, well, N2 reacts with hydrogen gas plus H2 goes to form ammonia, NH3. All right. Nitrogen gas reacts with, meaning it's a reactant, hydrogen gas. So they have to be on the left-hand side of that arrow to form ammonia. Well, if it's forming it, that's the product. So that goes on the right-hand side. Okay. Now, sometimes we'll give it to you set up like this. Sometimes we'll give it to you in a word. But what this is what's called a skeleton equation. Okay. It doesn't have, it's not balanced, but it gives you the basics behind it. So, like if you're doing a recipe, right, you're baking cookies and it's, oh, well, we need flour, we need sugar, we need eggs, we need chocolate chips, we need butter, whatever you need, and we're going to make chocolate chip cookies. You have this basic recipe here. It doesn't give you the quantities. It's not saying 1 cup of this and 2 cups of that, a tablespoon of this. That is what we're going to do in balancing. But this is now a skeleton equation. All right. And so let's see what we do with our skeleton equation. So these are step 1 and 2. We get ourselves to the skeleton equation, and then we move on to step 3. So we have our skeleton equation. Now we need to start to balance it. And the first step in balancing is to count the number of atoms on each side. So this arrow here is going to act as a barrier, okay? It's going to act as a barrier. And we need to make sure that everything on the one side is equal to everything on the other side. So you're going to count. Now you're going to do the atoms that are in the equation. So if we start off, we say, well, we have nitrogen. Well, how many are on the left-hand side and how many are on the right-hand side? So on the left-hand side here, we have 2 nitrogens. So we put in our 2. On the right-hand side, that subscript there is none, so it's assumed to be 1. So we have 1 nitrogen. All right, what about hydrogens? Well, on the left-hand side, we have, 2 hydrogens. And on the right-hand side, we have 3 hydrogens. All right, this is step 3. We count. Now, this is an easy example. There's only a couple atoms. Sometimes we can have a whole bunch. If your equation involves a polyatomic ion, OH, PO4, NO3, NH4, these polyatomic ions, then you can count them as a single unit if they stay the same on both sides. So if there's a CO3 on one side and a CO3 on the other side, you can count that as 1 unit and balance it that way. We'll see that in the future. Okay. So on to step 4, because we've done our counting. So step 4, now we're going to want to do our next, which is balance, right? Balance the elements one at a time by using coefficients. So you go back and forth and you add coefficients to make them even. So we say, all right, if we look at this, we have 2 nitrogens on this side, 1 nitrogen on the right, What do? Well, we're going to add a coefficient. We're going to put something here, which means we're going to multiply to make these even. So how do we make a 1 into a 2? Well, we multiply it by 2. So we put a 2 up here in the equation, and now we recount because we now have changed what we did. We now said, well, now instead of just having one ammonia molecule, instead of just having this one ammonia molecule on this side, we now, I guess I should put those electrons, we now have two ammonia molecules. And if we have two, our numbers change. Instead of having one nitrogen, we now have 2 times 1, right? 1, 2. So we have 2 nitrogens. They're now even. But we no longer have 3 hydrogens either because, again, everything doubles. So we have 6 hydrogens. Okay, well, now our nitrogens and our hydrogens are even, right? And if you want to see it on this side, we have 1 N2 molecule. We haven't changed that. And we have 1 H2 molecule. All right, so let's see what we need to do now. Because nitrogens are even, 2 and 2. Let's move on to hydrogen. We have 2 and we have 6. So how do we turn a 2 into a 6? Well, we got to multiply it by 3. So we say, well, where do we put it? In front of the N2, in front of the H2? Well, we're trying to change the H2. So we'll put it right in here. Well, 3 times 2 equals 6. So we now said, oh, we have 3 hydrogen molecules, right? 3 H2s, which means that we have 6 hydrogens. All right. Now our nitrogens are balanced, our hydrogens are balanced. We didn't put anything in front of this N2. Well, that's fine. It's assumed to be a 1 then. Okay. So we are now balanced. We've done our balancing. We used our coefficients. Everything is even. All right. So there's 2 more steps to just kind of wrap it up. All right. So step 5 says that you're going to check each. You're going to double check. That's all. You're going to ignore this stuff that you have here, and you're going to do a quick double check. And so you're going to say, well, let's go ahead and do this double check. Well, how many nitrogen do I have on each side? Okay, well, let's do a quick count. I have on the left 1 times 2, 2 nitrogens. On it, 2 times 1, 2 nitrogens, hydrogens. 3 times 2, I have 6 on the left. 2 times 3, I have 6 on the right. Do they balance? Yes, they do. And we double check just, guys. Sometimes it's very complicated. You're going to be going back and forth. And you can check your answer. You don't need to ask me if it's correct. You'll know if it's correct just by doing this. Okay? If you double check, you're going to always know if it's correct. Now, you might know, I don't know how to get the answer, but you're going to know I don't have the correct answer, or I do have the correct answer. All right, and last but not least, the very last thing you have to do is that these coefficients make a ratio. Okay, so step 6, these coefficients, they make a ratio. And so you have to make sure it's the lowest whole number ratio. So you look at these coefficients that you added. We have a 1, a 3, and a 2. They're now a ratio. 1 of these to 3 of these to 2 of these. Can I reduce that ratio? And of course the answer is no. We have a 1. You can't reduce a 1. It's the lowest whole number ratio. But you do need to reduce that ratio. So if we had a 2 and a 6 and a 4, the balancing would be correct. It's a ratio. But 2, 6, and 4 can be reduced to 1, 3, and 2. All right, now the only real way to learn this is to go practice it. So hop on that worksheet, give it some practice, walk guided solutions to walk you through as you're getting there, and have fun.